Hello Math 1093. In this video I want to build on some of the ways we've developed of thinking about sine and cosine and the other trigonometric functions for non-unit circles. So here I've drawn a circle which I'm not assuming is a unit circle. So I'm going to say not a unit circle here. It's a circle of some radius that we don't know the value of yet. Okay, so not a unit circle. Alright, and let's suppose I have some point out here somewhere. And I draw an angle in standard position, meaning that it starts at the positive horizontal axis and ends right here at this ray in that point. Okay, so let's call that angle an angle of measure theta. And let's suppose that I know the coordinates at that point. The coordinates are x, comma, y. And I want to know what the sine of theta is, the cosine of theta, all of that jazz, all six of them. Tangent theta, cotangent theta, secant theta, whee, and cosecant theta. All right. So sine of theta we've already talked about. We know that the sine of theta, assuming that this circle has radius r, so let's mark that as having radius r, the sine of theta is going to be the y coordinate over r. It's going to be that ratio. The cosine of theta is going to be x coordinate over r. But we haven't figured out these other ones yet. What are the tangent, cotangent, secant, and cosecant going to be in terms of x, y, and r? So we did define tangent of theta to be equal to sine of theta over cosine of theta. And if that's the case, then, well, the sine of theta is y over r, and the cosine of theta is x over r. So I can simplify that. So flip that second fraction and multiply by it and get, notice the r's cancel out, and I get y over x. Okay, and you may be familiar with that from your previous experience with these functions. The tangent function, or tangent of theta in particular, can be thought of as y over x. Okay, cotangent theta is going to be a similar story. I'm going to have cosine of theta over sine of theta. You may remember that cotangent of theta is just 1 over tangent of theta. That also can be an easier way of seeing this. Cosine of theta is going to be x over r divided by sine of theta, which is y over r. That's going to give me x over r times r over y, which comes out to x over y. Okay, now secant of theta we define to be just 1 over cosine of theta. Well, that's going to be 1 over what? Cosine of theta is x over r, so that's the same as 1 times r over x. So that is just r over x. And then cosecant of theta is going to be 1 over sine of theta, and that's 1 over y over r. And that's equal to 1 times r over y, so that's just plain r over y. Okay, so now we have values for all 6 trigonometric functions just in terms of the x-coordinate, the y-coordinate, and the radius of the circle. So now I'm going to use these to work on a little bit harder problem. So I'm going to give the following problem here. So here is the problem. Suppose we know the angle theta, or angle of measure theta, ends in quadrant 2. Remember, that's the upper left quadrant. And we know, suppose we know that the cosecant of theta is equal to 3. Okay, I just sort of picked a number there. Now, I didn't pick it totally haphazardly because I'm thinking ahead here and thinking, okay, that's going to mean that 1 over the sine of theta is equal to 3, which means the sine of theta is equal to 1/3. Now, you could easily imagine I could have picked a different value for cosecant of theta, and this might have come out to be some impossible number. Sine of theta equals 1/3 makes sense because sine of theta can be any number between -1 and 1. So this is between -1 and 1. But if sine of theta had come out to be something like 7, we'd be stuck here. But anyway, here's the problem. I haven't asked the problem yet. What are the values of the other 4 trig functions at theta? Okay, so all I know about theta is that it's an angle in the second quadrant. Let's mark that. Angle in the second quadrant whose cosecant is equal to 3. And from that, I figured out that the sine of theta was equal to 1/3. So I know those two things. I want to find the values of the other 4 trig functions. All right, so how am I going to attack this? Well, there's a couple of ways I could think about this. So I'm just going to write down a couple of strategies. So number 1 is I could draw a unit circle. So this is just sort of a cartoon of what I would do. And I could locate a point in the second quadrant whose sign looks like it's about 1/3. And I could try and figure out what the x-coordinate of that point would be. Once I have the x-coordinate, now remember this is assuming I have a radius of 1 here. Once I have the x-coordinate, I can then use that to figure out the cosine of theta. So whatever this is would be the cosine of theta. And then figuring out the others like the tangent and the cotangent and the secant wouldn't be too hard once I have the sine of theta and the cosine of theta. That's one strategy, but I actually want to illustrate a different one here, because doing all the fraction work associated with this first strategy can be kind of a pain. That strategy can work perfectly well. It is totally doable. Oops, need to select my pen here. Sorry about that. Doing the first strategy is fine if you're comfortable working with fractions, but if you'd rather not work with fractions, there's another way. Draw a circle of a different radius. I'll just say some other radius. Because one thing I know that the cosecant of theta is 3. And one thing that we established earlier, and let's see where we can find it here. There we are. Cosecant of theta is equal to r over y, the radius of the circle divided by the y coordinate. That's equal to 3, because I know that cosecant of theta is equal to r over y. Okay, now that doesn't mean that r has to have any particular value, nor that y has to have any particular value. For example, r could be 6 and y could be 2, and that would be just fine. But I'm going to pick values that are kind of easy to work with. So here is a possible value of r and y. Let's let r equal to 3 and y equal to 1. That is one possible choice, right? That would make r over y equal to 3. And now I'm going to draw a circle of radius 3 this time. So here's what my circle is going to look like. A little bit bigger this time. I guess it should really be 3 times as big. Okay, close enough though. Alright, so that's a circle of radius 3. Let's just mark that in here somewhere. There we go, overshot a little bit. And my y coordinate is going to be 1. Now I got to remember I'm in the second quadrant here. Remember the quadrants are marked like this. That's the fourth. I'm over in the second quadrant, so I'm up here somewhere at a y coordinate of 1. Okay, so I have some point here. Its y coordinate is 1, and it's on a circle of radius 3. All right, so what do I know? Well, I know that this circle of radius 3 has the following equation. It has an equation of x squared plus y squared equals r squared, and r in this case is 3, so x squared plus y squared is exactly 9. I know that y is equal to 1, so I could substitute that in and get x squared plus 1 squared equals 9. So x squared is equal to 8, which means that x has to be the square root of 8 plus or minus. Let's not forget that. So x has to equal plus or minus 2 times the square root of 2. And in this case, because I'm in quadrant 2, running out of space to write here. There we go. Let's write this in a different color. Because theta is in quadrant 2, x must be negative. So x has to be the negative 2 square roots of 2. All right, so now that I know that x is equal to negative 2 square roots of 2. I could even fill that in there. That's negative 2 square roots of 2. I know that y is equal to 1 at that point, so let's fill that out. And my r is equal to 3. So now I can come back here. I'm just going to transfer that information up here. Yeah, let's move up here and work. Okay, so just rewriting all of that stuff I just figured out. I know that x is negative 2 root 2, y is 1, r is equal to 3. And now I'm going to use this information to find the remaining values of the trig functions. So let's see, I was given that cosecant of theta was equal to 3. That was given in the problem. And from there we figured out sine of theta was 1/3. Now let's figure out all of the other ones. What's cosine of theta going to be? Well, that's going to be x over r. X was negative 2 root 2. R was 3. So that's it. I'll just put the negative sign on the outside of that fraction and be done. That's my cosine of theta. Secant of theta is actually just the reciprocal of that. I could also find it as r over x, but I'll just do this instead. It's 1 over negative 2 root 2 over 3. So flipping that fraction, I get negative 3 over 2 root 2. And I'm not going to bother simplifying it beyond that. If I needed to work with that number some more, I might, but I'm not going to mess with it. Tangent of theta is going to be, what's that? That's y over x. Well, I know that y is 1 and x is negative 2 root 2. So I get just plain negative 1 over 2 root 2. And again, if you want to simplify that so that there's no radical in the denominator, you can. You could multiply both the top and bottom by square root of 2. But I'm not going to bother. Finally, cotangent of theta is going to be x over y, which is negative 2 root 2 over 1, which is just plain negative 2 square root of 2. Okay, so there we have values of all 6 trig functions. Let's see if we can find them. There's 1, 2, 3, 4, 5, and 6. And all we were given was just one of them and the quadrant in which our angle theta was located. So just given those 2 pieces of information, we can find the values of all 6 trig functions, which is, I don't know, I think that's kind of cool. Might come in handy one day. All right, so in case you want to see the entire thing in one frame, there it is. I can't make it much bigger than that, but that should give you the chance to see all of the work in one frame, even though we really jumped all over the place. Okay, anyway, sorry that video was a bit long.